All right, so apparently listening to someone else explain these problems hasn't been good enough, and you've wanted my lilting voice to go over these problems for you. So here goes. Problem 1 in your notes, I'm taking point P and reflecting it over the line y equals 1. What you need to realize is that when you have an equation y equals a number, that's a horizontal line. Whereas, when the equation is x equals a number, that is a vertical line. This one, therefore, is a horizontal line passing through 1 on the y-axis. So here's 1 on my y-axis. Here's a horizontal line passing through 1 on the y-axis. My point P is 3, 4. It is located here. Problem is asking me to take that point and reflect it over the red line I've drawn for you. What you need to realize is that the black dot is 3 spaces above the red line. So since point P is 3 spaces above the red line, its image will therefore be 3 spaces below the red line. So from the red line, I count 3 spaces. 1, 2, 3. There is my answer point. And when I identify its coordinates, it is 3, -2. On the same grid, you're still starting with point P again. This time you're reflecting it over x equals 1. As I told you here, that's a vertical line. So it's a vertical line passing through 1 on the x-axis. It is here. Since point P is 2 spaces to the right of that green line, its reflected image will be 2 spaces to the left. 1, 2. There is my reflected image of P prime for this your turn, and it is located at -1, 4. In this problem, you're doing a rotation. That's what the lowercase r is indicating here. You're rotating it 90 degrees counterclockwise, as indicated here, and you're rotating it about the origin. That's the point 0, 0, indicated here. So we plot our points. P, 1, 1. Q at 3, 3. R at 4, 1. And S at 3, 0. Now, I can't do this on my screen, but hopefully you've been plotting along with me if you didn't already have these points on your graph. And what you should do at this point is take your piece of paper and turn it counterclockwise 90 degrees. And when you do, as you may have heard me say in class, your x-axis is now your y-axis, and your y-axis is now your x-axis. And now that you're looking at it through whole new eyes, P is now sitting at -1, 1. But guess what? That's the location of P prime. Q is now sitting at, and if you were looking at me right now, you'd be laughing because I'm in my classroom all by myself looking at my board sideways. Q is at -3, 3. R. Looking at it sideways, but hopefully you're looking at your paper that's turned sideways. Is at -1, 4. And S is at 0, 3. That's all they're asking you to do. In problem 5, when you listen to the link, they tell you to think of this point where the bishop is as 0, 0. And the bishop is making 2 separate moves. And then they're asking you, where is the bishop in relation to its original position? Okay, so what they're talking about in the video is that from here to here, in the first move, he went down 1, 2, 3, 4 spaces, and to the right 1, 2, 3, 4 spaces. And then from there, he went here, which is up to and right to. So from where he was originally located, if this point, his original location, is 0, 0, and this is where he ended up. I know it's hard to see maybe on that chessboard. What I'd hope that you realize is that he moved right 1, 2, 3, 4, 5, 6 spaces. So if I was to write a translation rule, since I'm moving right 6 spaces, my horizontal shift is 6. And from there, I'm down 2 spaces, and down is a negative direction. That's it. That's what they're asking you for. In the your turn, they say his next move is 3 squares left and 3 squares down. Okay, so from here, running out of colors here, there it is. From where that green dot just showed up, now I'm going 3 spaces down and 3 spaces left. Well, goodness. Then he's right back at where his first move was, here, which is down 4 and right 4. Well, right is the horizontal distinction, so that's the first number I write down, and right is a positive direction. And then down is a negative direction, so I write a negative sign, and he moved down 4 spaces from where his original location was way up here. That's the bottom line of what they're asking you. In problem 1, they're asking you to make a couple of observations of what happens when you reflect something over 2 lines. So if I were to take this Z and reflect it over line A, it would land, let's say, about here. And hopefully you'd realize it would be backwards because I reflected it. And then I'd reflect it again over line B. So it would be here. And what they're wanting you to realize is if the distance from A to B is, I believe on your papers, it's just shy of 1.5 centimeters. So let's just call it 1.5, just to round. If you were to measure the distance from here to here, it would be really stinking close to 3 centimeters. Well, notice the relationship between these two numbers. The distance of the translation is twice the distance between the two parallel lines. That's it. That's all they're asking you to really observe here, is the fact that from the original z to the ending z, it's a translation. And the distance equals twice, or 2 times, the distance between parallel lines. Even if I'm starting with the figure between the parallel lines. So in part A, it's saying draw parallel lines L and M, just like I had parallel lines in problem 1, and then draw a J between them. If I take line J, or if I take that J and reflect it over M, so it'd be kind of here, and then I take that reflection and I flip that over line L, it would be right about here. And once again, the distance for, this is a gross estimation, this is not exact, but the point that I'm trying to emphasize to you is if you compare the distance between these two parallel lines to the distance between these 2 points on the J's, what I would want you to observe is that the distance of the translation is once again twice the distance between the parallel lines. So in this part A here, when it says what is the distance of the resulting translation, it is still twice the distance between parallel, remember that's the symbol for parallel, lines. And then in this reasoning question, it's just asking us to use what we saw in problem 1 and in part A to make a conjecture, which is just an educated guess, about what happens anytime I reflect something over 2 parallel lines. Well, it happened twice, so it's probably a good educated guess that anytime I reflect something over a pair of 2 parallel lines, the resulting transformation is a translation, and I would hope that even without thinking the word, you realized, first of all, that I can't spell at this late hour, you would realize that the direction of the translation is perpendicular to the parallel lines. So the resulting transformation is a translation perpendicular to the parallel lines and having distance twice the distance between the parallel lines. And I know some stuff kind of overlapped here. I hope you were following along. Now what happens if I reflect stuff over intersecting lines, as indicated in problem 2? So here it's saying reflect the J, and there's the J. Reflect the J over line M, and then reflect it over line J. So if I reflect this J over line M, what I end up with is, it's kind of over here. And again, bear with me because I'm not using tracing paper. I'm just using my very old eyeballs at this very late hour. Okay, so there's my J that I end up with approximately after reflecting it over M. And then it's asking me to take that reflection and reflect it over line L. In order to do that, I need to extend this line because I ran out of line L there. When I do that, it's kind of flipping over on top of itself, and I end up with my J kind of here. And what ends up being really fascinating to a math nerd like myself is if I measure this angle from this point on J to this point of intersection of my two lines to this point on J, if I measure that angle, and kind of rusty with using this, so bear with me. I don't know if you can see it on your screen, but what I'd like you to notice is that the measure of this angle, it's hating me almost as much. Okay, it didn't like me trying to write on the protractor. But what I'd want you to notice is that the measure of that red angle that the protractor is superimposed on is 140. Think about that. The measure of that angle is 140. Notice that the angle formed by the intersecting lines was 70. That's fascinating. The angle formed after those two intersections is twice the angle of the intersecting lines. So when it says, what are the center of rotation? Well, do you see that from here? Let me move this protractor out of the way. Get out. From my original J to my ending J, what ended up happening was that I had a rotation. And the center of rotation is that point of intersection of the two lines, point C, and the angle of the rotation was 140 degrees. Okay, so let's answer the question. Center of the rotation, let's get this protractor out of my way. And the angle of rotation is 140. And in the interest of time, I'm not going to go through and do the that your turn. I got to get my son to football practice. Sorry, guys. But what I'd want you to realize is that the same thing would happen just like it did in the your turn for the parallel lines. So if I was to make an educated guess about what happens when I'm reflecting something over two intersecting lines is, I'm talking about the part B here, is that my center of rotation is the intersection of the two lines, and that the angle of rotation equals twice. Let me write the word twice instead of the two here. The measure of the angle formed by the intersecting lines. Finally, how do I come up with a congruence transformation? How do I figure out how I got from point A to point B? In this first one, problem 3, I'm trying to map JQV, this guy, to triangle EWT. So as I told you all, tracing paper, tracing paper, tracing paper. So I don't have tracing paper for my board, but I can take this triangle and I can turn it, if it cooperates with me, I can turn it and you'll notice it's close, but does it quite line up? Maybe. Let's see how far I would have to rotate it. So where was it? I love technology when it works. Okay, that's not working. It's really all kinds of not cooperating with me. All right, this triangle needs to go away because it's being naughty. There we go. Oh my goodness. Okay, let's try this again. If I take triangle J, Q, V. And I rotate it. Can I get it to land on this triangle? I don't think that I can. That's close, but not quite. But if I take this triangle and I flip it, do I have better luck in that regard? Oh, that looks really promising, huh, doesn't it? So what that means is, yep, there it goes. Okay, what that means is that they are not oriented the same. They are oriented opposite. So in plain old English, what that means is that in order to get from point A to point B, I'm going to have to do a reflection. And you can either reflect over the x-axis or you can reflect over the y-axis. And either way, you'll probably end up exactly where you need to go. Myself personally, as I'm looking at the way that the triangles are shaped, I would take triangle JQV and I would want to flip it over this y-axis. Okay, so I'm going to take my technology and hope that it's nice to me, and I'm going to flip it left to right. And when I do that reflection over the y-axis, it lands there. And using the proper notation, what I've done is I've taken this triangle, and I'll involve what the triangle is in a moment, but I've reflected it over the y-axis And so far it's right there. Now it's not where I need it to be yet. I still need to move it, hopefully you realize, up 1, 2, just lost myself. 1, 2, 3, 4, 5 spaces. And when I move it up 5 spaces, look at that. It is on there beautifully. Well, I just moved it up 5 spaces. I need to be able to use the proper notation. Remember, the circle here tells me that I've done something to something else. I moved something, that's a translation. I didn't horizontally shift it so that first number is a 0. Since I moved it up 5 spaces, this number is a 5. And if I really want to be a stickler about the notation, I can say, well, what did you do all of this to? And I would say, well, I did all of that to triangle JQV in order to get triangle EWT. And that's my congruence transformation that maps triangle JQV to triangle EWT. Finally, your turn. I'm trying to map triangle NAV to triangle BCY. And once again, I would trace the triangle, and I'll be honest with you, the first time I sat with this, I looked at it and I traced the triangle and I dragged the triangle over and I rotated it and I saw that it does line up. And I was all yippee skippy, okay, we're going to do a rotation. But look at the angle that I had to rotate this. This is not a 90-degree rotation or a 180-degree rotation or a 270-degree rotation. I mean, this is nasty. This is like this is 90, this is maybe 135. These are angle measures that I wouldn't want to deal with. So then I thought, let me look at these sides a little more closely and let me just, for kicks and giggles, let me flip it and see if that lines up. And, oh, well, that was kind of interesting because it did. Okay, so even though the orientation did work to do a rotation, it ended up being a whole lot easier to do a reflection. Okay, so let me flip that back over so we can talk about the whole process. Okay, so here's my original triangle. It's kind of being goofy now. Oh boy. Oh, good grief. Okay, so there's the triangle. And myself personally, I would take this and looking at this triangle and looking at the triangle that I'm trying to end up with, and the last one we flipped over the y-axis, and this one we're going to flip it over the x-axis. And could we end up with the right answer by doing it over the y-axis? Yes. It might take a couple of extra steps, and it's one of those things that once you do it a couple of times, you kind of get a feel for it, right? But I'm flipping this up and down, and when I flip this over the x-axis, this is where the triangle ends up. Okay, so this is the your turn that I'm doing now here. And so far I have reflected it over the x-axis, and once again I'm looking at where it is, I'm looking at where it's going, and hopefully you see This is, once again, a really easy shift. Oh, what did I just do? I broke it. Oh my gosh. That's not the letter O, it's a triangle. Silly. This is just an easy shift. Stop it. Of, come on. 1, 2, 3, 4, 5 spaces to the left in order to get where I'm going. So since we shifted it to the left is a negative direction, and we didn't go up or down, and we took triangle NAV to arrive at triangle BCY. I hope this helps. Have a great evening. Yeah, I was still recording, so be quiet.